The topic here is maxima and minima, intervals of increase or decrease, intervals where the graph is concave up or concave down, and then inflection points. So let's do this example. Let f of x equal x cubed plus x squared, and let's find the derivative. Okay, so we only need to use, it's pretty easy because all we need to use is the power rule. So the derivative of x cubed is 3x, 3 minus 1 is 2, so 3x squared, plus derivative of x squared is 2x, 2 minus 1 is 1. Pretty easy polynomial. For second question, we need to find the critical numbers. How do we find critical numbers? We set the derivative equal to 0, and then we solve for x. That's how you find critical numbers. So what does it mean derivative is equal to 0? It means 3x squared plus 2x, that's the derivative, we just found it right now. So you set it equal to 0 and you solve. So how do we solve that? Pretty easy, just factor the x. If you factor the x, you get 3x plus 2 equals 0, which means x is equal to 0, or 3x plus 2 is 0, which means x is equal to 0. 3x plus 2 is equal to 0 means 3x is equal to negative 2, means x is equal to negative 2/3. So those are my critical numbers. Now it says for question C, find x interval of increase or decrease. So it's pretty easy. All you need to do is the chart. So first thing we do, we take the critical numbers, they're right here, and then plug them in this line. And of course negative 2/3 is smaller than 0, so it goes on the left side. So this is negative 2/3, this is 0. Remember, the domain of polynomial is negative infinity to infinity, all real numbers. That's why I put on the chart from negative infinity to infinity. That's the domain. Now we know that the derivative is equal to 0 right here, so I'm just going to put a 0 to symbolize the derivative is equal to 0 there. When x is 0, f prime of 0 is also 0. So all I need to find is where the function is positive. I mean, whether the derivative is positive or negative. So let me write the derivative. Where do I write it? What's the easiest way? Let me write it here. It's probably easier. 3x squared plus 2x. Well, I made a mistake on the derivative. The derivative is, no, that's right. No, that's right. Alright, now all we need to do is to know where this is positive or negative. Just plug in numbers. For example, if you plug a number bigger than 0, like right here, we can pick 1, right? So let's plug in 1. Let me do it here. F prime of 1, you know how to plug 1. If you plug a 1 into the derivative, you get 3 times 1 squared plus 2 times 1. So it's 3 plus 2 is 5. So it's positive. So we know this is positive. Now let's plug in the easy numbers first. On the left of negative 2/3, if we pick a number on this interval, the easiest number would be negative 1. So f prime of negative 1, plug in negative 1 into the derivative, you get 3 minus 2 is 1, which is positive. So I know this is positive. And then plug a number between negative 2/3 and 0. So negative 1/3, so f prime of negative 1/3, which is equal to, if you plug it, you'll get, let me do it, so 3 times negative 1/3 squared plus 2 times negative 1/3. That's 3 times 1 over 9, so that's 3 over 9, which is 1/3 minus 2/3. So you can tell that's a negative number because that's going to be equal to negative 1/3. So less than 0, so this is negative. So now, since when the derivative is positive, the function is increasing. When the derivative is negative, the function is decreasing. When the derivative is positive, the function is increasing. So we know it's increasing it's increasing on negative infinity. Let me just do it here. F is increasing on negative infinity, negative 2/3 union from here to here, so 0, infinity, right? And F is decreasing from here to here, so on negative 2/3, 0. Now for question D, we need to find the second derivative. So second derivative is pretty easy. The derivative of 3x squared will be 2 times 3 is 6x, 2 minus 1 is 1, plus derivative of 2x is just 2. Right? Now, for us to be able to do next question, graph where it's concave up, concave down, we need to find the critical numbers for second derivative. Means we need to set this equal to 0 and solve for x. That's pretty easy. 6x plus 2 is equal to 0 means x is equal negative 2 over 6, which is negative 1 over 3. So to find the interval where the graph is concave up, concave down, we need to plug in the critical numbers for the second derivative. Means in this case negative 1/3. So the second derivative is equal to 0 here. So we can tell, and we want to know whether it's negative and positive. Second derivative is positive, is just plug in a 0 here. So if you do second derivative of 0, you get what? 2, which is positive. No, actually 0 is here. Sorry. Zero is on the right of negative 1/3. So this is going to be positive, and of course on the left it's going to be negative. So it's concave down here and it's concave up here. Now we need to find if there is any relative maxima and minima. Relative maxima and minima always happen where the function is decreasing and increasing. So this is going to be a relative maxima, because you can tell, see, even if you graph it, the graph is going to look like that. So you can tell it's a relative max. So relative max or local max is the same thing. Relative max is going to be equal negative 2/3, and then we need to find the y value. We need to plug a negative 2/3 into our function. We're going to do that soon. And then a relative min. Of course it happens here, see where the function is decreasing then increasing. See if you look at the graph. So it's a 0, it's f of 0, so the relative min point will be 0 and then f of 0, and if you plug 0 into our original function, the f of 0 is 0 cubed plus 0 squared, which is 0, so 0, 0. And then relative max, we need to plug in negative 2/3, so f of negative 2/3, which is negative 2/3 cube plus negative 2/3 square, which is 8 over 27 plus 4 over 9, which is equal 8 over 27, multiply by 3, you get 27, 12, so 20 over 27. So the relative max will be this y value, and it happens at x equal negative 2/3, and relative min will be 0, and it happens at x equals 0. So also we can also talk about inflection points. Since it's concave up and down, then the inflection point, let's do it here, inflection points will be negative 1/3 and then f of negative 1/3. So inflection point, we need to plug in negative 1/3, so let's plug it in here. F of negative 1/3 is equal to negative 1/3 cube plus negative 1/3 square, which is equal to 1 over 27 plus 1 over 4, which is equal to 4 plus 27 will be 31 over 27 times 4 will be 80 108. So 31 over 108. Right, so that's the inflection point. And that's it for this example.